Okay, in our last section of Chapter 2, we're looking for solutions, remember that's x, y values, that work for inequalities. And remember, inequalities are those greater than and less than symbols. And specifically, we're looking at solutions for x and y. So to help you think this through, I want you to think about what we did in the last chapter. If I asked you, give me solutions for x is greater than 10, you couldn't just tell me 11, 12, 13. There's infinite, even 10.5. 10 with any decimal works. So you had to graph your answers on a number line with an open circle at 10 going to the right. Well, now, if I look at example 1 and I'm asking you that to give me solutions for x and y that make this inequality true, well, we can only represent our solutions on a graph, on an x, y axis. So there's a few things we have to keep in mind about how to graph this. Just like in the previous chapter, you had to keep in mind an open circle correlated with the greater than symbol, and you had to shade to the right if it was greater than or to the left if it was less than. Well, because we have x and y, we also need to make sure that we're aware of how do these symbols work. So this is kind of like a key up at the top. If you have a less than or equal to, or a greater than or equal to, you're going to have a solid boundary line when you graph your graph. If you have a less than or greater than, you're going to have a dashed boundary line. And then if you have a greater than or equal to symbol, you're going to shade above your boundary line. Above boundary line. And if you have a less than or equal to, you're going to shade below your boundary line. So here's kind of your key for how we will be working. And let's go ahead and let's try it with an example. So here, give all the solutions. Graph y is greater than 3/2 x plus 1 and list the domain and range. Graph your boundary line. Oh, so here's the steps of how we would do this. We're going to temporarily replace our inequality symbol with an equal sign so that we can see, well, what type of graph do we have here? What will the line look like? Then we're going to use our key of how to shade the graph. So let's go with step 1. Step 1. We're going to replace the y is greater than 3/2 x plus 1 temporarily with an equal sign. So we have y is equal to 3/2 x plus 1. We know that this correlates with our y-intercept, so we're going to start at 0, 1, and this correlates with our slope, so our slope is positive 3 over 2. So we go to 0, 1, we go up 3, right 2, up 3, right 2, or again, you could go down 3, left 2. I'm not going to shade this line yet because I need to look at my inequality symbol to see how am I going to be shading. So here's kind of step 2. Step 2. Because it's a greater than symbol, look at your key, that means we're going to have a dashed line. A dashed boundary line. So I'm not going to shade this, I'm going to dash this. And what that means is every point on this line is not actually a solution to the inequality. What points are solutions to this? Well, the greater than sign means we're going to shade above our boundary line. So I'm going to shade every single line above, and every point in this region will be a solution to my inequality. Now please be aware this key only works if y is on the left side. So if you start with y on the right side, just go ahead and move that to the left side. But now let's do a little check step. Let's make sure that we can check our answers. And how do we check? We'll choose any point that's been shaded. So like this one up here, 0, 3. That's been shaded. So let's check it. 0, 3. We're going to plug it in into our equation. Y is greater than 3/2 x plus 1. Now we're going to ask, is 3 truly greater than 3/2 times 0 plus 1? 0 times anything is 0, so is 3 greater than 1? Check. So 0, 3 should definitely be shaded. Look at the boundary line. What the dashed means is that any point on your dashed line is not a solution to the inequality. So if I plug in any of these points, they should not work. Try this. If I plug in 0, 1, which correlates to this point, here's my equation here. I'm going to check this. Is the y value 1 greater than 3/2 times 0 plus 1? Is 1 greater than 1? No. So that's how you can see how this correlates. Okay, if I am looking at, actually, you know what, we're not going to look at domain and range for this, so go ahead and cross that piece out. Okay. All right, go ahead and flip it over. Let's try it with an absolute value expression. So let's do step 1. Go ahead and just cross off the domain and range. We're not going to do that for this section. Looking at the step 1, we're going to replace temporarily our inequality symbol with an equal bar. So we have y is equal to the absolute value of 2x minus 3. And we want to graph this. Remember, when you're graphing absolute value, you know it's going to be a v, but we don't know where the v will be located. So we have to start by finding the vertex. So take the inside, set it equal to 0, solve for x, and that's the x-coordinate of our vertex. Where does the y-coordinate come from? Exactly what's outside. So we have 0, negative 3 is our vertex. 0, down, 1, 2, 3. And then I need to find some more points. So I go ahead and I can create my table, x, y, choose values to the left and the right of the x-coordinate of your vertex. So I might choose like negative 1 to plug in. 2 times negative 1 is negative 2. The absolute value of negative 2 is 2. So we can look at this. Minus 3 would give us negative 1. So I have the point negative 1, and I can reflect that over. And let's plug in one more point like 2. The absolute value of 2 times 2 is the absolute value of 4. Minus 3 gives us 1. So we have the point 2, 1, and we can reflect that over. Now, before we connect these dots, we have to look at step 2 and see what type of boundary line do we have. Well, we have a greater than or equal to symbol that was given to us in the example. So that means we're going to have a solid boundary line, and we're going to shade above. So I have a solid boundary line, meaning every point on this absolute value line makes the inequality true, and we shade above. So I probably want to extend this even further and say every point inside here, and show that it goes forever, is a solution to our inequality. Okay, so the last piece that we look at then is, can you determine from the boundary line given what inequality symbol should be placed or replaced in place of the equal sign to match the graph? So here's our boundary line. What type of symbol corresponds to a dashed line that has been shaded above the graph? Hopefully you're thinking dashed means there's no equal bar, shaded above means greater than. So we should have a greater than symbol replacing that equal. So we have y is greater than the absolute value of x minus 2 minus 1. And then go ahead and try this last example here. Oh, and it didn't get copied for you very well. Let's see if we can figure out what line this is. It has a y-intercept of 3, and it has a slope of 1 left 2. So the slope is negative 1/2. So my boundary line should be y equals negative 1/2 x plus 3, my y-intercept. But now what type of inequality symbol should replace this? Hopefully you're thinking, because I shaded below the line and I have a solid boundary line, I should have a less than or equal to. That corresponds to shading below and a solid boundary line. So we would have y is less than or equal to negative 1/2 x plus 3.